The aluminum gleamed under the harsh electric lights of the Seattle factory floor, catching the October sun that filtered through the vast industrial windows. Major Wilhelm Schneider stood motionless, his polished boots planted on the concrete, as a completed B-17 bomber, fully armed, fully fueled, ready for war, rolled past him toward the tarmac. He checked his watch. 87 minutes had passed since the previous aircraft had made this same journey. Around him, the thunder of riveting guns, the screech of metal on metal, and the coordinated movement of thousands of workers created a symphony that should have been impossible. It was October 1938, and Schneider had just witnessed something that would haunt him through every bombing raid of the coming war, the moment he realized Germany had already lost. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The delegation had arrived in Seattle 3 days earlier, part of a broader industrial exchange program between Nazi Germany and American aviation companies. The arrangements had been made through proper diplomatic channels, with Boeing's management eager to showcase American engineering prowess and perhaps secure future contracts. Schneider led a group of 7 Luftwaffe officers, each selected for their technical expertise in aviation production, logistics, or combat operations. They wore civilian clothes at Boeing's polite insistence, though their bearing and cropped hair marked them unmistakably as military men. Their mission was simple: assess American aviation capabilities, identify potential weaknesses in design or production philosophy, and report back to Göring's Air Ministry with recommendations for Germany's expanding aircraft industry. Schneider himself had served in the Great War, flying reconnaissance missions over the Western Front in 1917. He remembered the material superiority of the Allies even then: the endless columns of trucks, the mountains of artillery shells, the steady stream of fresh American troops arriving in the war's final year. But that war had ended 20 years ago, and Germany had rebuilt itself under the Führer's guidance. The Luftwaffe was the most modern air force in the world, its pilots the best trained, its aircraft the most advanced. The Heinkel He-70, the Messerschmitt Bf 109 taking shape in Augsburg factories. These were machines that represented the cutting edge of aviation technology. Surely America, fat and complacent in its ocean-protected peace, could not match the focused military-industrial machine that Germany had become. The Boeing plant sprawled across acres of what had recently been pasture land south of Seattle. Plant 2, where the delegation spent most of their time, had been completed just months earlier, a massive structure of steel and glass designed specifically for the production of the B-17 Flying Fortress. The building itself dwarfed anything Schneider had seen in Germany. The main assembly hall stretched nearly a quarter-mile long, with ceiling heights that accommodated the bomber's full wingspan. Natural light flooded the workspace through skylights and vast window panels, eliminating the gloomy, cramped conditions typical of European factories. The floor plan followed a revolutionary assembly line concept, borrowed from automobile manufacturing but adapted for the complexity of aircraft construction. Their Boeing guide, a production engineer named Harold Matthews, explained the layout with obvious pride. "We've organized everything around continuous flow," he said, gesturing across the factory floor. "Each station performs specific tasks, and the aircraft moves progressively down the line. By the time a frame reaches the end, it's a complete airplane." Matthews had served in the Army during the Great War, and he recognized the type of men he was showing around, regardless of their civilian attire. He answered their technical questions thoroughly, perhaps too thoroughly. Boeing's management had approved nearly unrestricted access, confident that American Industrial might speak for itself. The delegation watched as a bare airframe entered the assembly line. The B-17's distinctive fuselage took shape in sections, each built on specialized jigs that ensured perfect standardization. Workers swarmed over the structure, their movements choreographed through months of training. Pneumatic riveting guns chattered in rhythmic bursts. Overhead cranes swung wing sections into position with surprising delicacy. The Germans noticed immediately that many workers were women, a sight virtually unknown in German aircraft factories where such work was considered unsuitable for females. Matthews noted their reaction. "We're training anyone who can do the job," he explained. "The work isn't about strength. It's about precision and attention to detail." Schneider's colleague, Captain Ernst Hoffmann, an engineer who had helped design production facilities for the Messerschmitt works, pulled out a notebook. He began calculating production times, worker-to-aircraft ratios, square footage per manufacturing station. The numbers emerging from his pencil troubled him. "How many workers on this floor?" he asked Matthews. "This shift has about 1,200, Matthews replied. "We run 2 shifts currently, with plans for 3, if military orders increase." Hoffman's pencil paused. 1,200 workers on a single shift, in a single building, all focused on one aircraft type. The largest German aircraft factory, Messerschmitt's Regensburg plant, employed fewer workers across its entire operation, and Boeing was just one company. Hoffman had read about Douglas, Lockheed, Consolidated, Martin, major aircraft manufacturers scattered across the American continent, each with multiple facilities. The assembly process itself revealed a philosophical difference that went beyond mere scale. German aircraft production emphasized craftsmanship. Skilled metalworkers hand-fitted components, making minute adjustments to ensure perfect alignment. Each aircraft was, in a sense, a unique creation, built by teams of artisans who took pride in their individual contributions. The approach produced superb aircraft, but slowly. The Messerschmitt Bf 109, Germany's frontline fighter, required approximately 4,000 man-hours to complete. Skilled workers were the bottleneck, and skilled workers took years to train. Boeing's approach eliminated the craftsman. The B-17's components were manufactured to tolerances so precise that they required virtually no fitting. Parts were interchangeable, across different aircraft, different production lines, even different factories. A wing rib built in Seattle would fit perfectly on a fuselage assembled in Long Beach. Workers repeated simple, specific tasks rather than mastering the entire aircraft. A woman who had never seen an airplane before could be trained in a few weeks to install hydraulic lines or rivet aluminum panels. The system transformed aircraft construction from an art into a process, and the efficiency gains were staggering. On the second day, Matthews walked them through the subassembly areas where B-17 components were manufactured before reaching the main line. Here, the scale of American industrial preparation became more apparent. In one vast room, workers assembled nothing but engine cowlings, producing them in batches of 20. In another, tail sections took shape on specialized jigs, multiple units at various stages of completion. Raw aluminum arrived by rail car from smelters on the Columbia River, already formed into standardized shapes, ribs, longerons, skin panels, that needed only to be assembled according to engineering drawings. Lieutenant Dieter Krause, the youngest member of the delegation and a pilot who had flown the Heinkel He 111 during the Spanish Civil War, asked to see the engines. Matthews led them to a separate building where Wright Cyclone radials were prepared for installation. The R-1820 engines arrived from the Wright plant already assembled, tested, and ready for mounting. Workers installed them in pairs onto engine cradles, connecting fuel lines, electrical systems, and control cables before the entire assembly was lifted by crane onto the waiting B-17 wings. The process took hours rather than days. Krauss studied the Cyclone engine with a pilot's eye for mechanical reliability. Each radial displaced 1,800 cubic inches and produced over 1,000 horsepower. 4 of them gave the B-17 a total of more than 4,000 horsepower, enough to carry 5 tons of bombs to targets 800 miles away. The engine itself was a marvel of American manufacturing. Cylinder heads and pistons machined to microscopic tolerances. Crankshafts forged from special alloys, superchargers enabling high-altitude performance. But what struck Krauss wasn't the engine's sophistication. It was the quantity. Racks of completed Cyclone engines filled the building, maybe 40 or 50 units awaiting installation. And Matthews mentioned casually that Wright Aviation's New Jersey plant produced these engines in considerable numbers for multiple aircraft types. That afternoon, they witnessed what their hosts called a rollout. A completed B-17, its aluminum skin still unmarked by military insignia, was towed from the final assembly station toward the factory's massive doors. Matthews checked his watch and smiled. "That's number 43 for this month," he said. "We should hit 45 by the 31st. Schneider did the mathematics automatically. 45 aircraft in 1 month from one factory from one company. At that rate, Boeing alone would produce more than 500 B-17s in a year. And this was peacetime production, built on civilian contracts and export orders. What would these numbers become if America entered a war? What would happen when all those other manufacturers, Douglas, Lockheed, Consolidated, shifted to military production? The delegation toured Boeing for 5 days, and each day brought new revelations that chipped away at the comfortable assumptions they had carried across the Atlantic. On the 3rd day, Matthews showed them the quality control processes. Random aircraft were pulled from the line and subjected to intensive inspections, their components measured against engineering specifications. Defects were tracked statistically, with entire production runs halted if error rates exceeded acceptable thresholds. The Germans appreciated quality control, but the systematic nature of Boeing's approach, the reliance on statistical analysis rather than master craftsman's judgment, represented a different philosophy entirely. On the 4th day, they visited the parts warehouse. Here, the true scale of American industrial logistics became undeniable. The warehouse held inventory for 3 months of production, millions of rivets, miles of electrical wire, tons of aluminum stock, thousands of instruments and components. Matthews explained that Boeing maintained relationships with over 700 suppliers across the country, each delivering standardized parts according to precise schedules. The logistics network resembled a military supply chain, except it served the construction of machines rather than the feeding of armies. Captain Hoffman spent hours in the warehouse, walking between pallets of components, opening boxes to examine contents, questioning the inventory managers about lead times and backup suppliers. That evening, over dinner at their Seattle hotel, he shared his calculations with Schneider. "They're building an infrastructure for mass production," Hoffman said quietly, mindful of other diners. "Everything we saw, the factory layout, the standardized parts, the supplier network, the worker training programs, it's all designed to scale up rapidly. Right now, they're producing 45 bombers per month, but the system could support 10 times that number with only modest expansion." Schneider nodded slowly. He had reached similar conclusions. "The workers," he said. "Did you notice how quickly they learned their tasks?" Matthews mentioned that most had been farmers or clerks 6 months ago. "They're not skilled metalworkers. They're not craftsmen. They're just people following instructions, and yet the aircraft they produce meet military specifications." "Exactly," Hoffman replied. "In Germany, We would never accept such an approach. We value skill, expertise, tradition. But the Americans have eliminated the need for expertise. They've engineered the skill out of the process. Any factory worker can build a B-17, which means every factory worker could build a B-17. He paused, his engineer's mind working through the implications. If war comes, and if America enters it, they could turn their entire industrial economy toward military production. Automobile factories could build aircraft. Radio manufacturers could make avionics. Steel mills could supply raw materials at unprecedented volumes. And the workers? They could train millions of workers in months. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The final day of their visit included a demonstration flight. A factory-fresh B-17 took off from Boeing Field with a test crew and several of the German officers aboard. Schneider chose to remain on the ground, but Krause and 2 other pilots jumped at the opportunity. They returned 90 minutes later, subdued. The B-17, Krause reported, was not as fast or as maneuverable as German bombers, but its defensive armament was impressive. Multiple machine gun positions covering virtually every approach angle, and its range, its bomb capacity, its high-altitude performance. These capabilities were designed for a specific type of warfare that Germany's medium bombers could not match. The B-17 was built to fly deep into enemy territory, above fighter opposition, and deliver massive bomb loads with precision. It was built, in other words, to destroy German cities from beyond the reach of defending fighters. The major leaned back in his chair, studying the German officer across the table. "Walk me through it again," he said. "That moment in Seattle. When exactly did you realize what you were seeing?" Schneider closed his eyes, and the memory returned with perfect clarity. "The second day," he said quietly. "We were standing on an observation platform overlooking the main assembly floor. Matthews, our guide, was explaining the production schedule. He mentioned casually that they were behind target. Only 40 bombers, that is, month instead of 45. Behind target. As if producing 40 strategic bombers in 30 days was somehow disappointing. He opened his eyes. In Germany, our most advanced factories took 3 months to produce 40 aircraft of any type. And here was this American, apologizing for his factory's inadequate performance. The interrogation sessions continued through the summer of 1945. Allied intelligence wanted to understand German decision-making, the intelligence failures, the strategic miscalculations that had led to such catastrophic defeat. Schneider provided what information he could, but he found himself returning repeatedly to that October visit to Seattle, the pivotal moment when he had glimpsed the future and been unable to convince anyone of what he had seen. Other members of the original delegation had not survived the war. Captain Hoffman, the engineer, had died during a bombing raid on the Messerschmitt Regensburg plant in August 1943, killed by bombs dropped from the same type of aircraft he had watched being built 5 years earlier. Lieutenant Krause, the young pilot, had been shot down over France in 1944, his Focke-Wulf 190 overwhelmed by American P-47 Thunderbolts that appeared in such numbers that individual skill became meaningless. 3 other delegation members had perished in various circumstances. Only Schneider and 1 other officer, Major Georg Richter, had survived to witness the final collapse. Schneider met Richter in the POW camp in July. They had not spoken since 1939, before the war, when both had been busy with their separate duties. Richter had spent the war years in logistics, managing supply chains for Luftwaffe units on the Eastern Front. He had witnessed firsthand the progressive deterioration of German material capabilities as Allied bombing destroyed factories, rail networks, and fuel production facilities. "Do you remember what you said to me?" Richter asked one evening, as they sat in the camp compound, watching the sun set over the Bavarian mountains. "After we returned from America, you said that we had seen the future, and the future was German defeat. I thought you were being dramatic. I thought you had been impressed by American showmanship, by their big factories and their mass production rhetoric. I didn't believe that their system could actually work under wartime conditions. And now?" Schneider asked. "Now I know you were optimistic," Richter replied bitterly. "Your estimates were too conservative. The Americans didn't just match what you predicted. They exceeded it. And they did it while also supplying Britain, supplying Russia, feeding half of Europe, and maintaining a civilian economy that kept their population comfortable throughout the war. We were rationing bread in 1942. They were rationing nothing." The conversation turned to the specific failures that had compounded Germany's strategic mistakes. The decision to invade the Soviet Union while Britain remained undefeated, splitting German forces across two fronts. The declaration of war on America after Pearl Harbor, a decision that baffled both officers since it provided no military advantage and unified American opinion behind total war. The persistent belief that one more offensive, one more tactical victory, one more technological breakthrough would somehow reverse the fundamental material imbalance. "We kept thinking we could innovate our way to victory," Richter said. "The jet fighters, the V-weapons, the new U-boats. Every few months there was some new program that would supposedly change everything. And some of those innovations were genuinely impressive. The Me-262 was decades ahead of Allied fighters. But what difference did it make? We built maybe 1,000 jet fighters. The Americans built 50,000 conventional fighters. Innovation cannot overcome that level of material disparity." Schneider had reached similar conclusions. German technological sophistication had produced remarkable weapon systems: jet aircraft, ballistic missiles, advanced submarines, revolutionary tanks. But these achievements consumed enormous resources while producing limited quantities of weapons that arrived too late to affect the war's outcome. Meanwhile, the Allies had focused on producing adequate weapons in overwhelming quantities, accepting that their Sherman tanks were inferior to German Panthers, but building 50,000 Shermans against 6,000 Panthers. The American approach, good enough, in sufficient numbers, delivered on time, had proven strategically superior to the German pursuit of technical perfection. The interrogations revealed that Allied intelligence had tracked German awareness of American industrial capacity throughout the war. Schneider's reports had been intercepted and decoded, along with other German assessments of Allied production capabilities. American analysts had found it remarkable that German leadership continued aggressive military expansion despite possessing accurate information about the material forces arrayed against them. The conclusion among Allied intelligence officers was that Nazi ideology had blinded German decision-makers to mathematical reality. They had convinced themselves that racial superiority, tactical brilliance, and willpower could overcome industrial capacity. But Schneider believed the truth was more complex and more human. "It wasn't just ideology," he explained during one session. "It was the nature of military organizations. Officers are trained to focus on the factors they can control: tactics, training, equipment quality. We're taught that superior leadership and fighting spirit can overcome numerical disadvantage. And historically that's often been true. But industrial warfare changed the equation. In this war, material capacity was destiny, and no amount of tactical skill could alter that fundamental reality. Accepting it meant accepting defeat, and military officers are not psychologically equipped to accept inevitable defeat. So we kept fighting, kept planning, kept believing that somehow circumstances would change. One American intelligence analyst, a lieutenant colonel named Edwards, who had worked in War Department planning before the war, spent considerable time questioning Schneider about the Boeing visit. Edwards had his own copies of Schneider's 1938 report, translated into English, with annotations from American analysts who had read it after the war. "Your production estimates were impressively accurate," Edwards said. "You predicted that Boeing alone could produce 600 B-17s annually if fully mobilized. They actually produced over 700 per year at peak production. You estimated total American aircraft production capacity at 15,000 per year in wartime. The actual figure exceeded 25,000 by 1944. How did you calculate those numbers?" "I didn't calculate them," Schneider replied. "I observed them. Matthews showed us everything: the factory layout, the supplier network, the worker training programs, the inventory systems. Anyone with manufacturing knowledge could see that the entire operation was designed for rapid scaling. The building was twice as large as necessary for current production. The assembly line had excess capacity built in. The supplier network could obviously support higher volumes. It wasn't a factory operating at maximum capacity. It was a factory deliberately built to expand production when needed. The Americans weren't hiding their capabilities. They were demonstrating them, perhaps as a deterrent, hoping that potential enemies would recognize the futility of challenging American industrial power." Edwards nodded thoughtfully. "That was exactly the intention. Boeing's management, with government approval, wanted foreign observers to understand what American industry could accomplish. The thinking was that transparency about industrial capacity would discourage aggression. If potential enemies knew they couldn't win a production war, they wouldn't start a shooting war." "It didn't work," Schneider said simply. "We saw everything, reported everything, understood everything, and we went to war anyway. Because the alternative was accepting that Germany's strategic position was hopeless, that the entire National Socialist project was doomed by geographical and industrial realities that no amount of military effort could overcome. No government could accept that conclusion. So we convinced ourselves that American power was exaggerated, that Americans lacked fighting spirit, that the war would be over before American industry could fully mobilize. We believed what we needed to believe." The conversations with Edwards continued intermittently through August and September. The intelligence officer seemed fascinated by the psychological aspects of strategic decision-making, the ways that organizations convinced themselves to ignore unpleasant information. He shared with Schneider some American intelligence assessments from the pre-war period, documents that had estimated German military capabilities with considerable accuracy. "We knew how strong you were," Edwards said. "We knew about the Luftwaffe expansion, the Panzer divisions, the tactical innovations. Our War Department understood that Germany had built the most effective military force in Europe, and that knowledge shaped our planning. Roosevelt and the military leadership knew that if war came, we needed overwhelming industrial superiority to compensate for our lack of military preparation. That's why we started expanding aircraft production in 1939, 2 years before Pearl Harbor. We were building the arsenal while still technically at peace." Schneider found himself developing a certain respect for Edwards and the other American officers he met. They had won the war through industrial brute force, but they weren't arrogant about it. They understood that their victory owed more to geography and resources than to superior virtue or fighting quality. The American soldiers Schneider encountered in the POW camps were professional, generally fair, and remarkably uninterested in vengeance. They had done their jobs, won their war, and wanted to go home to resume their civilian lives. In October 1945, 7 years after his visit to Seattle, Schneider was transferred to a special detention facility where the Allies held German officers with technical expertise. The war crimes tribunals were beginning at Nuremberg, but Schneider's record showed no involvement in atrocities or criminal activities. His value lay in his knowledge of aviation industry and his documented attempts to warn German leadership about Allied industrial capacity. American and British intelligence services were already thinking about the post-war world, about the emerging rivalry with the Soviet Union, about the need to rebuild Western European defenses. Officers like Schneider, who had opposed Hitler's strategic decisions and possessed expertise in military production, might prove useful in the coming years. During this period, Schneider was given access to comprehensive production statistics from all combatant nations. The numbers told a story of such overwhelming disparity that even he, who had predicted German defeat based on industrial capacity, found them staggering. The United States had produced 300,000 military aircraft. Germany had managed approximately 130,000. But more revealing than total numbers were the production curves. German aircraft production had peaked in 1944 at roughly 40,000 units, achieved despite constant bombing and resource shortages through heroic efforts by workers and managers. American production that same year exceeded 96,000 aircraft, built in factories that operated without fear of attack, supplied with unlimited raw materials, staffed by millions of well-fed workers. The tank statistics were similarly lopsided. Germany produced approximately 25,000 tanks and assault guns during the war. The Soviet Union, supplied with American raw materials and machine tools, built over 100,000. The United States manufactured nearly 90,000 tanks while simultaneously producing 50,000 aircraft, millions of trucks, countless artillery pieces, and enough naval vessels to control every ocean. American shipyards had built one major warship every 3 days for 4 years, a production rate that seemed impossible even after witnessing Boeing's Seattle plant. But perhaps the most revealing statistics concerned logistics and supply. Schneider read intelligence reports about American logistics operations with something approaching awe. The U.S. military had transported 12 million personnel overseas during the war, supplied them continuously across both Atlantic and Pacific theaters, maintained equipment in operational condition despite harsh combat environments, and done it all while the American civilian economy continued producing consumer goods. German logistics, by comparison, had struggled to supply armies fighting within Europe on interior lines, using captured resources to supplement domestic production. The organizational capacity required to project military power globally while maintaining domestic prosperity revealed an industrial and administrative sophistication that Germany had never approached. One document particularly captured Schneider's attention, a logistics study of the 8th Air Force's operations from British bases. Each B-17 bomber required approximately 20 tons of supplies per month to maintain combat operations, fuel, ammunition, spare parts, replacement equipment, food for the crew. At peak strength, the 8th Air Force operated over 2,000 heavy bombers. That meant 40,000 tons of supplies needed to be transported across the Atlantic monthly, just to support the strategic bombing campaign against Germany. And that was only one component of Allied operations in Europe. The total logistics requirement for all American forces in the European theater exceeded 1 million tons of supplies per month by 1944, all of it shipped across 3,000 miles of ocean, protected against U-boat attack, unloaded at ports, transported to forward units, and distributed to individual soldiers. The Americans had built a military supply chain that functioned with the reliability and scale of a peacetime civilian economy. They had solved problems of transportation, inventory management, standardization, and distribution that would have seemed impossible to pre-war military planners, and they had done it while simultaneously maintaining equally massive logistics networks in the Pacific Theater, supporting British and Soviet forces with Lend-Lease supplies, and keeping their domestic population fed, clothed, and reasonably comfortable. Edwards visited again in December. They had developed something approaching friendship over the months of conversations, the German officer and the American analyst finding common ground in their shared fascination with the intersection of industrial capacity and military power. "What will you do after this?" Edwards asked. "When you're finally released?" Schneider shrugged. "Return to Germany, I suppose. Try to rebuild something from the ruins, though I don't know what place there will be for someone like me. A Luftwaffe officer who warned against the war, who predicted defeat, who was proven right. That's not a comfortable position in a defeated nation. People don't like being reminded of mistakes, especially catastrophic ones." "You might consider coming to America," Edwards suggested. "We're going to need people who understand aviation industry, who can help us think about future military production requirements. The war with Japan just ended, but no one thinks we're entering an era of peace. The Soviets are going to be a problem, and we need to maintain industrial readiness without bankrupting the country. Your insights about production scalability, about the relationship between civilian and military manufacturing, that knowledge is valuable." The suggestion surprised Schneider. "You would hire German officers after everything?" "We hired German scientists," Edwards replied. "Von Braun and his rocket team are already working for us. We're practical people. The war is over. The question now is how to prevent the next one, or win it if prevention fails. And that requires understanding industrial warfare at the level you understand it. You saw what American industry could accomplish before we even knew it ourselves. That perspective is rare and valuable." Schneider didn't commit to anything that day, but the conversation opened possibilities he hadn't considered. The world was entering a new era, one where strategic bombing and industrial production would remain central to military power. The lessons of the recent war, the decisive importance of manufacturing capacity, the futility of tactical brilliance against overwhelming material superiority, the need to think in terms of industrial systems rather than individual weapons. These lessons would shape whatever conflicts emerged in the coming decades. In February 1946, Schneider was released from detention. He returned to Germany, to the ruins of Berlin, and tried to resume some form of normal life. But the offer from Edwards lingered in his mind. In June, he accepted a position with the U.S. Strategic Bombing Survey, helping American analysts assess the effectiveness of the bombing campaign against German industry. The work took him back to the factories he had once helped build and defend, now reduced to rubble and twisted steel. He walked through the remains of the Messerschmitt Regensburg plant where Hoffmann had died, the Focke-Wulf Bremen facility that had produced fighters for the Luftwaffe, the synthetic fuel plants that had kept German aircraft flying until Allied bombs destroyed them. The irony wasn't lost on Schneider. He had predicted that American industrial power would prove decisive. He had warned that Germany couldn't win a production war against the United States. And now he was helping the Americans document exactly how their industrial superiority had been translated into military victory. The Boeing plant in Seattle, the factory he had visited in October 1938, had produced nearly 13,000 B-17s during the war. Those aircraft had dropped more than 600,000 tons of bombs on German targets. The machines he had watched rolling off the assembly line every 90 minutes had, multiplied 1,000-fold, destroyed the country he had tried to defend. But there was no bitterness in the recognition, only a kind of exhausted acceptance. He had understood the trajectory from the beginning. He had seen where it would lead, had tried to warn those who might have changed course, and had been ignored. The tragedy of the war, from his perspective, wasn't that Germany had lost. Defeat had been inevitable once the conflict expanded to include American industrial might. The tragedy was that it had happened at all, that millions had died fighting a war whose outcome was predetermined by factors that had nothing to do with courage, skill, or sacrifice. The soldiers who had fought so desperately, the civilians who had endured such suffering, the cities that had been destroyed, all of it had been pointless. The working out of mathematical equations that anyone with basic knowledge of industrial production could have calculated in advance. Years later, after Schneider had emigrated to the United States and built a quiet career as a consultant for defense contractors, he occasionally gave lectures at military staff colleges about strategic planning and industrial mobilization. He would describe that October day in Seattle, standing on the factory floor while B-17s rolled past with mechanical regularity, watching American workers who barely understood what they were building construct weapons that would devastate his homeland. And he would tell his audience, usually young officers confident in their training and their nation's power, that the most important strategic question was never, can we win this battle? But rather, can we sustain this conflict against an opponent with superior industrial resources? Because in modern warfare, he would explain, tactical victories are temporary and strategic defeat is mathematical. The story always ended the same way, with Schneider checking his watch in that Seattle factory, timing the interval between aircraft completions, doing the calculations in his head and understanding in that single moment of clarity that everything he had believed about Germany's military position was illusion built on hope rather than reality. 90 minutes from bare frame to completed bomber. 45 aircraft per month from one factory. Multiply by the number of factories, by the years of war to come, by the thousands of other weapons those same industrial systems would produce, and the result was inevitable. Germany had lost the Second World War in October 1938 on a factory floor in Seattle, when the first of 12,000 B-17s rolled past a German officer who finally understood what his nation's leadership refused to accept, that industrial capacity was destiny, and America's industrial capacity was beyond comprehension. The lectures sometimes drew criticism from military historians who argued that Schneider oversimplified the war's complexity, that he ignored crucial factors like tactical innovation, strategic mistakes, or the decisive contributions of Soviet manpower on the Eastern Front. And Schneider would acknowledge these points with a slight nod, conceding that no single factor determines history's course. But then he would return to his central thesis with the patience of someone who had lived through the proof of his argument. Consider the Eastern Front, he would say to his audiences. Yes, Soviet soldiers bore the brunt of fighting against Germany. Yes, their sacrifice was immense and their contribution to Allied victory was decisive. But what sustained the Red Army through 1941 and 1942, when German forces were driving toward Moscow and Leningrad? American trucks, 400,000 of them delivered through Lend-Lease. American locomotives and railway cars that kept Soviet supply lines functioning. American aluminum and aviation fuel that allowed Soviet factories to produce aircraft. American food that fed Soviet workers and soldiers. The courage was Russian, but the logistics were American. He would pause, letting the point settle. The Soviet Union had manpower and determination. Britain had strategic position and organizational skill, but neither could have sustained a long war against German military power without American industrial support. That's not diminishing their contributions. It's recognizing that modern warfare requires material foundations that only industrial capacity can provide, and America's industrial capacity exceeded the combined output of all other nations. These lectures often attracted veterans who had served in various theaters, men who wanted to challenge Schneider's thesis based on their own combat experiences. A former tank commander once stood during the question period, his voice sharp with memory and pride. "I fought in a Sherman," the man said. "I know it wasn't as good as a Panther or a Tiger, but we won anyway. Doesn't that prove that industrial quantity can't completely overcome quality?" Schneider's response was gentle but firm. "You won because you had 5 Shermans for every German heavy tank. You won because when your Sherman was destroyed, another arrived within days. You won because American factories produced spare parts, replacement engines, ammunition, fuel, everything necessary to keep armored divisions in continuous operation. Yes, the Sherman was technically inferior, but it was reliable, easy to maintain, simple to repair, and available in unlimited quantities. Those qualities matter more than armor thickness or gun caliber when fighting an industrial war." He would reference specific examples from his post-war work with the Strategic Bombing Survey. "We studied German tank production carefully. The Panther was a magnificent tank, possibly the best designed armored vehicle of the war, but it required specialized components, precise manufacturing, skilled assembly workers. Each Panther took twice as long to build as a Sherman, required 3 times the maintenance hours, and broke down more frequently under combat conditions. The Germans built 6,000 Panthers. The Americans built 50,000 Shermans. Even if we assume each Panther was worth 3 Shermans in combat, a generous estimate, the arithmetic still favors American production by a factor of more than 2 to 1. The mathematical arguments usually convinced the technically minded officers in his audiences, but Schneider recognized that numbers alone couldn't capture the full psychological and strategic reality of the industrial disparity. So he would sometimes describe what German soldiers reported experiencing during the final years of the war. The sense of being overwhelmed not by superior tactics or courage, but by sheer abundance. German troops would destroy an American supply dump, congratulating themselves on a tactical success, only to watch as an even larger supply dump appeared in the same location a week later. They would shoot down bombers by the dozen, celebrating each kill, then face larger formations the next day as if their victories had been meaningless. That was the American advantage, Schneider would explain. Not that each individual weapon was better, but that losses were irrelevant. An American bomber crew that was shot down could be replaced within hours. New crew from the training pipeline, new aircraft from the factories, new bombs from the arsenals. A German fighter pilot who was killed represented an irreplaceable loss because the training infrastructure couldn't produce pilots fast enough, and the industrial base couldn't replace aircraft quickly enough. By 1944, we were training pilots with perhaps 20 hours of flying time before sending them into combat against American pilots who had hundreds of hours of training. Not because German training was inadequate, but because we couldn't afford the fuel, the aircraft, or the time necessary for proper preparation. The fuel shortage particularly illustrated the cascading effects of industrial disparity. Germany's synthetic fuel plants, marvels of chemical engineering, produced gasoline and diesel from coal through a complex and resource-intensive process. At peak production, these plants supplied perhaps 20% of Germany's peacetime petroleum needs, barely adequate for a military at war. Allied bombing systematically destroyed the synthetic fuel infrastructure during 1944, and Germany lacked the industrial capacity to rebuild quickly enough. By early 1945, Luftwaffe aircraft sat grounded for lack of fuel, while American and British planes filled the skies, powered by petroleum from Texas, California, and the Middle Eastern fields that American companies had developed. This is what I tried to explain in my 1938 report, Schneider would tell his audiences. Industrial capacity creates resilience, America could lose battles, lose equipment, lose personnel, and absorb those losses without strategic impact because the industrial base continuously regenerated military power. Germany, by contrast, fought with finite resources. Every loss was permanent. Every destroyed factory, every killed pilot, every sunken cargo ship. These losses accumulated until the military became a hollow shell, still fighting, but no longer capable of sustained operations. In his later years, Schneider returned to Germany occasionally, visiting the rebuilt cities and meeting with former colleagues who had survived the war. Some had prospered in the new Federal Republic, finding places in the post-war government or in the reconstituted German military forces under NATO. Others remained bitter about the defeat, unable to accept that their sacrifice had been in service of a lost cause. Schneider found these encounters difficult. He had been proven right about industrial capacity determining the war's outcome, but there was no satisfaction in the vindication. Being correct about disaster is not the same as preventing it. He met once with a former Luftwaffe general, a man who had commanded fighter wings during the Battle of Britain and the defense of Germany. They sat in a cafe in Munich, drinking coffee and speaking quietly about the war that had consumed their youth and destroyed their country. The general, older now and worn by years in Soviet captivity, asked the question that Schneider had asked himself countless times. Could anything have changed the outcome? If we had listened to your report, if we had understood American industrial power, what would have been different? Schneider considered the question carefully. We would have avoided war, he said finally. That's the only rational response to recognizing that you cannot win. Hitler's entire strategic vision depended on quick victories, on defeating enemies before they could mobilize fully, on preventing a long war that Germany's limited industrial base couldn't sustain. If the leadership had accepted that American entry into any European conflict meant inevitable German defeat, then the logical conclusion was to avoid antagonizing America at all costs. Don't ally with Japan. Don't declare war after Pearl Harbor. Perhaps even avoid invading Poland, if Britain's alliance with Poland might eventually draw in American support. But that would have meant abandoning everything, the general said. The entire National Socialist project, all of Hitler's goals, they all required military expansion. Yes, Schneider agreed. Which is why my report was ignored. It didn't just predict defeat in a war. It demonstrated that Germany's strategic ambitions were incompatible with industrial reality. No one wanted to hear that message, so they convinced themselves it was exaggerated or that circumstances would somehow be different. And millions died because we couldn't accept mathematical truth. They sat in silence for a time, watching Munich's traffic flow past, the rebuilt city showing few scars from the bombing that had once reduced it to rubble. American aid had helped finance the reconstruction. American industrial capacity turned toward peaceful purposes, building rather than destroying. The irony was almost too perfect. The same industrial might that had devastated Germany now lifted it from ruin, demonstrating again that manufacturing capacity shaped history more than military force ever could. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.